I hope that you tried the problem and that you did it. If you have not, please push pause on this video and do the problem on your own. We would like to find out whether our critical values produce relative maximums, relative minimums, or neither a relative maximum nor a relative minimum. And we're going to do that at each critical value. We're going to do that using the first derivative test like we've seen before. I have left all my work up from when we found the critical values of 7/3 and 1. If you need a refresher, go back and look how we got those. So we had critical values of 7/3 and 1 from -infinity to 1. My function h of x was increasing. From 1 to 7/3, my function h of x was decreasing. From 7/3 to infinity, my function h of x was increasing once again. So again, if you think about what's happening, we're increasing from -infinity up to 1. At 1, we take a downturn and we're decreasing up until we hit 7/3. And once we hit 7/3, we're increasing again. So we're at 1 and we're at 7/3. So we're going to get a relative maximum when our critical value is 1, and we're going to get a relative minimum when our critical value is 7/3. So we can just write that down. We have a relative maximum when x equals 1, and we have a relative minimum when x equals 7/3. If you wanted to find these are the critical values. If you wanted to actually find the critical point, you could plug in 1 and 7/3 and actually find the relative maximum and find the relative minimum, respectively. So that's how you do problems like this. We find the critical values. We decide to the left of this number, is it increasing or decreasing? To the right of this number, is it decreasing or increasing? If we go from increase to decrease, that means we have a relative maximum. If we go from decrease to increase, that means we have a relative minimum. And if we do increase, then increase again, we have neither. If we have decrease, then decrease again, then we have neither.